What is going on, everybody? Got another video here for you. This is solving differential equations in an applied calculus class. This is the second applied calculus class, part 2. Solving differential equations, undetermined coefficients. All right, so, or non-homogeneous linear equations. In the previous videos, we did homogeneous equations, where it was this f of x here was 0. All right, so let's see what we do. So it says, let's consider the solution of a non-homogeneous linear equation of this form here, and it equals f of x, where f of x is a function of x or it's a constant. The solution is of the form y equals y sub c plus y sub p. And in this, y sub c is called the complementary solution and is obtained by solving the corresponding homogeneous equation. All right, so to find y sub c, that's what we did in the last couple of videos. Okay, that's where you do that. You rewrite it in terms of m and you solve it, okay? And then y sub p is the particular solution. So this is the new part, okay, from the previous videos, the particular solution. All right, so we've got the method of undetermined coefficients. So depending on what f of x is, now this is, f of x is what it's set equal to, this part right here. Okay, so we look at the f of x, and based on what f of x is, if it's a constant, then we choose our particular solution to be a. If it's a linear function, we choose our y sub p to be ax plus b, and so on. I'm not going to read through all these. You can pause the video and write them down. But this is what we use. And, your teacher may or may not give you this list for your test. If you're in my class, I'll give you the list for the test. Okay. All right, so let's see what we've got. And see if we can work through some problems. All right, so the first thing we're going to do is we're just going to state the particular solution. Okay, so we're not solving any differential equations right now. All they're doing is they're telling us, okay, f of x is this. What would you choose y sub p to be? All right, so let's take a look at that. So we have f of x equals 4x. So this is a linear function. So you can see up here the linear function, we choose it to be ax plus b. So we would choose y sub p to be ax plus b, and that's what you would choose. All right, so for the second one, we've got x squared plus e to the negative x. Now on this one, notice that we have different ones. We have x squared, okay, x squared plus e to the negative x. So we have a quadratic, which is this right here. So we've got ax squared plus bx plus c. So we may have to combine some. So yp is ax squared plus bx plus c. And then we look at this e to the negative x. Well, here's e to a power. Don't mistake it with this one, because this one, see, this has an x in front. So we've got this e to the 5x, so that's just going to be a e to whatever exponent we have. So we've got negative, so that's going to be plus e to the negative x. Now we use a, b, c, and yes, we could use d as a constant, but I'm not using the d because some of these problems are written, the derivatives written in this form, and I don't want to get this d confused with the d for the constant. So we'll avoid using d as a constant. All right. And so this is your answer here. Now what about this one? E to the x plus x e to the x. Okay, so really we don't have anything up here. Yeah, we've got this and we've got this. Okay. But would it be this one plus this one? Well, let's look at this. So for this one, we could actually look at this as 1 plus x times e to the x if we factor out e to the x. Okay. So we've got a linear here, so that's ax plus b times e to the x. Well, the e to the x, that's just a e to the x. Or we could write this as e to the x. This is yp. And so we get yp is equal to ax e to the x plus b e to the x. And this would be your particular solution here. All right. All right, so what about this one? Well, notice this one right here, it's kind of like this, isn't it? But, you know, we're looking at this and we're thinking, well, it's almost like it, but it's not. But if we come up here, we notice we have it right here. See that? And so this yp is going to be ax e to the negative 2x. I'm using this one right here, plus b e to the negative 2x. And then we have this constant. So when you have a constant, that's just a. But, you know, we've already used the constant a, so we'll put plus c. We'll use c as that constant. Now, what about this one? How would we do this? Well, we have a linear times a trig function. Okay, so let's see. The linear is ax plus b, and the trig function sine is going to be cosine plus sine. Okay, so for this one, we would have what? Yp is equal to, well, the linear is ax plus b times what? Times, let's see, where is it? There we go. Times cosine x plus not ax, plus cx plus e. Remember, we're not going to use d, times sine x. And so we would get yp is equal to ax. And all I'm going to do now is I'm just going to distribute the trig function. So let's distribute them like this. We're going to have, well, we can write it ax cosine x plus cx sine x plus b cosine x plus e sine x. So I put the ones that have the x terms together and the ones that don't, I put those together. So I just distributed each of those. Okay, and this is it right here. Now what about this one? So don't get confused here. We got 2x plus 4x squared. So you might look at that and say, hey, well, that's a linear plus a quadratic. But no, this right here, it's just a quadratic function. So if we have a quadratic function, what is it? It's ax squared plus bx plus c. And so we get yp is ax squared plus bx plus c. And that would be your answer. All right. So now we've worked through a few examples of choosing y sub p. Now let's solve some equations. All right. So what do we have to do? Remember, y is equal to y sub c plus y sub p. So we've got to find the complementary solution, and we've got to find y sub p. See, just like it said up here. We got to find the complementary solution, y sub c, and particular solution, y sub p. All right. So y sub c, that is solving the homogeneous equation. Remember, that's what it said up there. Said it right here. It's called y sub c is called the complementary solution and is obtained by solving the corresponding homogeneous equation. So we set it equal to 0 and solve. And like I said, this is what we did in the last couple of videos. So that's m squared minus m minus 6 equals 0. So m minus 3 times m plus 2 equals 0. And so m equals 3 or m equals -2. And so for y sub c, we get c1 e to the negative, e to the 3x plus c2 e to the -2x. So there's our complementary solution. Now we need to find y sub p. So notice we have e to the x. So you've got to come up here and make a guess at y sub p, which we're going to use this one. So it's this. And so we're going to choose y sub p is equal to a e to the x. Okay. And what do we need? Well, we've got the y sub p, which we're going to plug in for y. Now we need the first derivative and we need the second derivative. So y prime sub p, well, that's just a e to the x. And y double prime sub p is just a e to the x. Okay, this is an easy one. Derivative of e to the x is just e to the x. All right, and then what we do is we take each one of these and plug them back in. So we're going to plug this in for the second derivative. We're going to plug this in for the first derivative, and we're going to plug this in for y. So we've got a e to the x minus a e to the x minus 6 times, and then this is going to be plugged in for y, a e to the x, and that equals this e to the x here. And so, well, those go to 0, so we get -6a e to the x equals e to the x. And so for these to be equal, well, -6a, the coefficient of the e to the x over here, has to equal the coefficient over here, which is 1. And so we get a is -1/6. So we get y sub p is equal to, now look at this. See, y sub p is a e to the x. Well, what's a? A is -1/6, so that's -1/6 e to the x. And then remember, y is y sub c plus y sub p. And so we get y is equal to y sub c, which is this, c1 e to the 3x plus c2 e to the -2x, and then plus y sub p, and this is y sub p, minus 1/6 e to the x. And this is your solution. All right? So that's not too bad. I left myself a lot of space for these problems. All right. So let's find the complementary solution first. So we've got to do this. We've got to solve the corresponding homogeneous equation. So m squared plus 4 equals 0. m squared equals negative 4. M is equal to plus or minus 2i. All right. All right. Now, what is our complementary solution? Well, our complementary solution is y sub c equals, that's going to be c1 sine, well, okay, so let's write this all out in detail, okay? All right, so remember, on this one, we've got alpha equals 0 and beta equals 2, okay? So this is going to be c1 e to the 0 times x times sine of 2x plus c2 e to the 0x cosine 2x. So yc is c1. This is just 1. So that's sine 2x plus, this is, see, that's 1 and that's 1. c2 cosine 2x. So there's your complementary solution. Now, we've got to choose y sub p. So we've got a linear. That's going to be ax plus b. And you know, if you haven't done so already, what I would do is, if you haven't copied those, if you haven't copied this down right here, I would copy this down, and then you would have it with you as we work through the video, okay? So for our constant term, because I'm not going to keep going back and forth, but I will on this one. Say I'm sorry, I don't know why I said constant term, but for our linear term, that's ax plus b, and then we have this minus 4e to the negative x, which is going to be this one right here, okay? And so that's going to be plus c e to the negative x. See, we got the negative x right there. And so that's the guess where, that's what we're going to choose for our y sub p. And now let's see, we're going to plug this in for y, and then we need the second derivative to plug in. So we've got the first derivative is just a, and then derivative of this is minus c e to the negative x, and then y double prime, well, the derivative of a is 0, and then derivative of this would be positive c e to the negative x. And so then we have to take this and plug in. So we're going to plug this in for the second derivative. So that's going to be c e to the negative x, and then plus 4 times, and then in the place of y, we're going to put this. That's going to be ax plus b plus c e to the negative x, and that equals x minus 4e to the negative x. Now, let me say this. You see how this is written? This is how this textbook writes the problems. But this would be the same thing as if we wrote the problem like this. Y double prime minus 4y equals x minus 4e to the negative x. Okay? Oh, put my subscript p there. All right, so I mean, it's the same thing. This book uses this the book I'm teaching out of uses this notation a lot. Okay. All right, so now we've got c e to the negative x plus 4ax plus 4b plus 4c e to the negative x equals x minus 4e to the negative x. And so we'll combine our like terms over here. So we're going to get 4ax plus 4b plus 5c e to the negative x. All right. And that equals x minus 4e to the negative x. All right. So you see our x term here? This is the only term that has an x. The coefficient's 1, so I know 4a has to equal 1. There's no constant. See, 4b is just a constant. There's no constant over here, so 4b is equal to 0. And then you see this e to the negative x. Well, that's a negative 4. This is 5c, so 5c has to equal negative 4. So we get a is 1/4, b is 0, and c is negative 4/5. And so now we get our particular solution. Well, let's write this up here. A is 1/4, and b is 0, and c is negative 4/5. Yeah. And so we've got to plug this back into here. So we get yp is equal to 1/4 x. B is 0, so that term's just gone. And then plug this in for c, minus 4/5 e to the negative x. All right, so let's see. We've got our particular solution here. We've got our complementary solution. And so that's going to give us y is equal to y sub c, which is c1 sine 2x plus c2 cosine 2x plus 1/4 x plus y sub p. See, this is y sub c plus y sub p. So 1/4 x minus 4/5 e to the negative x. And this is a 4. And this is your answer right here. Okay. All right. So, so far, not too bad. I mean, they can get nasty, when you start taking derivatives and stuff, they can get pretty bad. All right. So we've got d3y minus 3d2y plus 2dy equals 0. Okay, and keep in mind this is y triple prime minus 3y double prime plus 2y prime equals 10 sine x, in case your book uses this notation. Okay, it's just a different notation for the derivative. This is third derivative, second derivative, first derivative. Okay, all right, so we've got m cubed minus 3m squared plus 2m equals 0. And so we factor out an m. And so m equals 0, or, and then we've got, let's see, m minus 2 times m minus 1 equals 0. So m equals 2 or m equals 1. So our complementary solution is y sub c is equal to, that's going to be c1 e to the 0 times x plus c2 e to the 1 times x plus c3 e to the 2 times x. And no, it doesn't matter, which one of these you write first. I just did it 0, 1, 2. I just started with the smaller one and worked my way up. So yc is just c1 plus c2 e to the x plus c3 e to the 2x. So there's our complementary solution. Let's just go ahead and underline that in red because we know we're going to need it again. All right, now let's make a guess at our y sub p. So that's sine, okay? So remember what sine is? It's cosine times sine. Cosine sine. See, one more time. I said I wasn't going to go up here again, but I guess I will. There we go. Let's see, that was equal to sine. So remember, sine is a cosine plus b sine. All right. Like I said, write that down. All right, so we've got, let's write this here. We got yp is equal to, and we'll do a, let's see, a cosine x plus b sine x. And you know, if you write a sine x plus b cosine x, that's fine too. It's the same. I'm just using what I have written down on my chart, on my list there. Just writing it in that order. And look at this. To plug this in, we actually need the third derivative, don't we? You see that? All right. So I've got y prime p is equal to negative a sine x plus b cosine x. Y double prime p, that's going to be negative a cosine x minus b sine x. And y triple prime is going to be a sine x minus b cosine x. So I just took the derivatives. And now we got to plug all of that into this thing. Let me see if I can take this. All right. Let's just drag this on down. Let's drag it right here. Okay. All right. So I'm just doing that so I can see what I'm plugging in. That's going to be, see, this is going to be a long one. So plug this in for the third derivative. So that's going to be a sine x minus b cosine x minus 3 times, now we plug the second derivative into here, negative a cosine x minus b sine x. And then this one plus 2 times, and then plug in the first derivative, negative a sine x plus b cosine x. And that equals 10 sine x. Now I got it all on there. All right, so now we're just going to have to distribute the parentheses. Hopefully I won't make a stupid mistake. Let's see, a sine x minus b cosine x plus 3a cosine x plus 3b sine x minus 2, minus 2a sine x plus 2b cosine x equals 10 sine x. And we're going to need to combine like terms. So let's do this. Let's underline all the sine terms in green, and we'll underline the cosine terms in red. Help us keep it straight. So that's going to be 1. Well, that's an A and a B there, and that's an A. So that, let's see, let's write this as 3b sine x, so that takes care of that one, minus a sine x. And then let's see, the cosine, that's going to be plus 3 cosine x, and then minus b plus 2, that's going to be plus b cosine x. I'm going to go back and check myself, so if I wrote something down wrong, I'll fix it. All right, so the thing I forgot is that should be 3a right there. So plus 3a cosine x. All right, so to make this a little easier, let's write this as 3b minus a times sine x. We'll factor out a sine. And then this one, that's going to be plus 3a plus b cosine x equals 10 sine x. All right. So now let's look at this. You see the sine x here and the sine x here? See this sine x and this sine x? Well, look at look what's in front of them. So this tells me 3b minus a has to equal 10. And then there's no cosine. So this means that 3a plus b has to equal 0. And so this tells me that 3a is equal to b. So b is 3a. So if I take this and plug it into here, that's going to be 3 times 3a minus a equals 10. And so 9a minus a equals 10. So 8a equals 10. So a is equal to 10 over 8, which is, what is that, 5/4? Well, there's a dumb moment there, isn't it? Look at that. This is, I don't know why I did that. Look at that. B is equal to negative 3a. That's going to make a little difference, isn't it? All right, so we've got 3 times negative 3a minus a equals 10. So negative 9a minus a equals 10. So negative 10a equals 10. A equals negative 1. All right. And so that means b is equal to negative 3 times negative 1. So b is equal to 3. All right, so a is negative 1, b is 3. So a is equal to negative 1, b is equal to 3. So we got to plug that into here. So we get, and I'm going to write yp here. Yp is equal to negative cosine x plus 3 sine x. All right. So there's your yc, yp, and so y is equal to c1 plus c2 e to the x plus c3 e to the 2x. Okay, so y is y sub c, which is this, plus y sub p, which is this. So minus cosine x plus 3 sine x. And there's your answer. And just to show you that it's not going to matter if you write your particular solution as a cosine plus b sine, or if you write it a sine b cosine, because the book I'm teaching out of, they actually did y sub p. They actually did it as a sine plus b cosine, and we still get the same answer. Okay, you're going to get the same answer. All right. All right, so hopefully that made sense. It's really not that difficult to do. I mean, this problem here was just a little more tedious, had a little more work involved in it. Okay, so let's look at this one. Find the particular solution of this. Okay, so they give us conditions here. Okay, so they've got y double prime plus 16y is equal to 2 e to the negative x, and yeah, they wrote that dy equals negative 2. So you can write it like this, or you can write y prime equals negative 2 and y equals 1 when x equals 0. Okay, it's notation is all it is. That's it. Okay. All right, so we've got y double prime plus 16y equals 0. So we have to solve the homogeneous equation first. So y squared plus 16 equals 0. So not y squared, but m squared. M squared is negative 16. M is plus or minus 4i. All right, so once again, our complementary solution, YC. So remember, alpha is 0. Alpha equals 0. And beta equals 4. Okay. Remember, go back to the video right before this one. Okay. Go to the video before this one. That's how we're solving these for the complementary solution. All right, so we get let's see, C1 e to the 0 times x times sine 4x plus C2 e to the 0 times x cosine 4x. So YC is C1 sine 4x plus C2 cosine 4x. All right, so there's your complementary solution. Now, let's choose our particular solution. So YP, well, we've got 2e to the negative x, so that's going to be ae to the negative x. So y prime is negative ae to the negative x, and y double prime is ae to the negative x. All right. So now we have to take that and plug it into this. And let's just go ahead and rewrite the equation down here so we can see it. So that's y double prime plus 16y equals, what is it, 2e to the negative x, I believe. Yeah, 2e to the negative x. So we got to plug this in. So I'm going to plug this in for the second derivative. So that's going to be ae to the negative x plus 16. And then for y, we're going to put in this ae to the negative x. Ae to the negative x equals 2e to the negative x. And so we get 17 ae to the negative x equals 2e to the negative x. So 17a equals 2. So a is 2 over 17. So this tells us that our particular solution is 2 over 17 e to the negative x. All right, so we get y is equal to our complementary solution, which is C1 sine 4x plus C2 cosine 4x plus 2 over 17 e to the negative x. All right. Now they want us to find the particular solution. Notice they gave us these conditions here. So when x is 0, so that means whenever we plug 0 in for x, when we plug it into y, we should get 1. And when we plug it into the first derivative, we should get -2. So basically all this means is that y of 0 is equal to 1 and y prime of 0 is equal to -2. Okay, so let's write that down over here. So we've got y of 0 is equal to 1 and y prime of 0 is -2. All right, so we know we can plug the 0 into here, and that should equal 1, and we should have an equation we can solve. But we've also got to plug the 0 into the first derivative and set that equal to -2. So let's go ahead and find the first derivative. So the first derivative, which is the derivative of this, that's going to be 4c1 cosine 4x minus 4c2 sine 4x minus 2 over 17 e to the negative x. So there's your first derivative. All right, so we get y of 0 is equal to c1 sine of 4 times 0 plus c2 cosine 4 times 0 plus 2 over 17 e to the negative 0, and that should equal 1. All right, so this isn't too bad. So look at this. We've got this equation here that we can solve. All right. Now, what's the sign of 0? The sign of 0 is 0, so this term goes to 0. The cosine of 0 is 1, so that leaves us with C2. And then e to the 0 is 1, so 1 times 2 over 17, so that's plus 2 over 17 equals 1. And so this tells us that C2, let's see, move that over. That's going to be, is that 15 over 17, I believe? Yeah, C2 is 15 over 17. Now we have y prime of 0, so we're going to plug 0 in for x right here. So that's going to equal 4c1 cosine of 4 times 0 minus 4c2 sine of 4 times 0 minus 2 over 17 e to the negative 0. And that should equal negative 2. See this negative 2 here. And so let's see, this is going to be 4c1, because cosine of 0 is 1, so that leaves 4c1. This term's going to 0, and then minus 2 over 17 equals negative 2. And so this tells me that 4c1 is, let me see, that's 2 over 17, 2 over 17 minus 2, when I add the 2 over 17 to both sides, and that is going to give me negative 32 over 17, and then I multiply everything by 1/4, and so that should be C1 is that negative 8 over 17? Yes. All right, so we've got everything. So now we know that y is equal to C1 times sine, so that's negative 8 over 17 times sine 4x. See, all I'm doing now is I'm taking the C1 and what I got for C2, and I'm plugging it back into here. And then that's going to be, let's see, plus 15 over 17 cosine 4x plus 2 over 17 e to the negative x. And this is your answer. All right. All right, so that's not too bad. A little work involved in that one. Okay. So now let's look at this one. I believe, yeah, this is the last problem. Okay, so make sure you watch this one. It looks pretty simple. So we take and solve. So we've got m squared minus 2m plus 1 equals 0. So that's m minus 1 times m minus 1 equals 0. So we've got m equals 1 or m equals 1. It's repeated root. So do you remember about the repeated root when you get a repeated root? So yc is equal to c1 e to the 1 times x, which is x, plus c2 x e to the 1 times x, which is x. Okay, like I said, go back to the previous video right before this one, and you can see it. Let me look real quick and see what the name of that video is. It's probably going to be called auxiliary equation with repeated or complex roots. Okay, so look for that video. That's where I went over all this stuff. Okay, if you're on this section in your class, then you've already had a lesson on this, what we just did there. All right, so now let's make our guess at y, or choose yp. Okay, so that's going to be ax plus b plus, now this is our proposed solution for yp. So I've got the linear x, so that's the ax plus b, and then e to the x, that's just going to be e to the x. All right. Now, this is where it gets tricky. This didn't happen in any of the other problems, and that's why I didn't mention it, but I'm mentioning it now. Oh, and I need to put a c there. C e to the x. All right. So notice how this right here, is similar to this solution here in our complementary solution. So we can't have that. So instead of c e to the x, we need to multiply it by x. So that's going to be cx e to the x, because we don't want it to be similar to this one right here. Okay. But now notice once we multiply this times x, it's now similar to this term, and we don't want that either. So we've got to multiply it times x again. So basically you're multiplying it by x squared. Okay. So what you're wanting to do is you're wanting to multiply it by the smallest power of x so that it's not similar to anything in your complementary. Okay. And you can see there's no x there. There's an x to the first there. So the smallest x power would be the x squared. Okay. All right. So now here comes the fun part. I dread doing this one. All right. So first, let's just take this and move it down here, because these derivatives are not going to be fun. All right. So, we need the first and second derivative. And you can see here, what do we have to do? We've got to use product rule. So y prime p, that's going to be a, that's 0, plus, okay, product rule. So that's 2xc e to the x plus cx squared e to the x. We have to use the product rule. So it's the derivative of the first term. So derivative of cx squared is 2xc times the second e to the x plus the first term, which is cx squared, times the derivative of the second, which is e to the x. So, I mean, not as bad as I thought it would be, but I mean, it gets ugly, it gets nasty. All right, so now the derivative of this. So derivative of a is 0, and then we got to use a product rule here, so that's going to be 2c e to the x plus 2xc e to the x. Okay, so this is the derivative of this term using the product rule. Now I got to take the derivative of this using the product rule. So that's 2c x e to the x plus cx squared e to the x. And yes, now we've got to take that and we've got to plug it into this thing. And let's just bring this thing on down so we can see what we got here. All right. Well, here we go. Okay, plug it in. So this is going to be 2c e to the x plus 2xc e to the x plus 2cx e to the x plus cx squared e to the x. All right, so that's for the second derivative, minus, all right, minus 2 times the first derivative, which is a plus 2xc e to the x plus cx squared e to the x, plus, and then y is that ax plus b plus c x squared e to the x, and that equals x plus e to the x. Forgive me if I have a careless mistake in here. Okay. So now what we want to do is we want to I guess, well, we need to clear the parentheses, combine like terms, do all that good stuff. So that's 2c e to the x plus 2xc e to the x plus 2cx e to the x plus cx squared e to the x. Now I'm going to distribute the negative 2. Minus 2a minus 4x c e to the x minus 2cx squared e to the x plus ax plus b plus cx squared e to the x. Let me move this. Move it up here, equals x plus e to the x. So that equals x plus e to the x. Now let me go through here and see what terms I can combine. All right, so I went through and looked. Okay, so look, these, see the terms in red, they all cancel out, and the terms in green, they all cancel out. And basically what we're left with is this term, and this term, they're constant, so they just add together. And then we got this term, and that's it. So, you know, it was nasty, but it turned out pretty good. Okay, you can pause the video before I scratched all this out and, you know, go through it yourself and check out, but they cancel out. So here we can see, you see our term with the x. Okay, so that tells me that a is equal to 1, the coefficients of x. And then we have 2c equals 1, so c equals 1/2. And then I have negative 2a plus b equals 0. Okay, well, a is 1, so that's negative 2 times 1 plus b equals 0, so b is equal to 2. Okay, so there's your A, B, and C. Okay. So let me go and grab, let me grab these two, because there's our complementary and our particular solution. And let's bring this on down so we can look at them. Okay. All right, so we've got y is equal, well, first let's do this. So this tells me that yp is equal to a, which is 1, so that's x plus 2 plus 1/2 x squared e to the x. Okay, and so y is equal to y sub c, which is this one, and I know that don't look like a c, but it is. So that's going to be c1 e to the x plus c2 x e to the x plus, so that's y sub c plus y sub p, x plus 2 plus 1/2 x squared e to the x. And there's your solution. All right, so that's the video. Okay, I hope you enjoyed it. Some of the problems got kind of nasty, but, you know, overall it's not too bad. So, you know, just the main thing here is, you know, when you're dealing with all this stuff right here, what we're doing right here, all this kind of stuff, just take your time. That's all you got to do. It's easy to make a simple mistake. That's why after I wrote everything down, I paused the video and I went back through and checked to make sure I didn't write anything down wrong, didn't have a careless mistake or anything like this. Yeah, I've got the book here. The problems are worked out, but I didn't write my particular solution the same way they did. I used the variables. I'm sorry, the letters, the A's, the B's, the C's, the C1, the C2. I might have had those in front of different terms. So I wasn't going to match what they had here, but I still got the same answer. Okay, so that's why I couldn't look at the book and check it. I had to pause and go back and double check and make sure I had it, didn't have a stupid mistake somewhere. All right, but anyway, I'll shut up now. So I hope you enjoyed it. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I'll see y'all in the next one. Later.